Hi folks, welcome to another set of ICP video notes. Today we're going to learn about the difference between temperature and thermal energy, how thermometers are able to measure temperature, and how we can convert between the three different temperature scales. So let's start off with the difference between thermal energy and temperature. You already know that thermal energy is based off of the kinetic energy of the particles in a substance. You may not know, however, that it's the sum of all of the energy of all of the particles in that substance. So if you find all of the kinetic energies of each particle in a substance and add them all together, that'll get you the thermal energy. You've probably been qualitatively measuring the hotness or coldness of an object since you were a little kid. However, thermometers allow us to quantitatively measure it. In other words, it helps us to put a number to what that temperature is. Temperature is also based on the kinetic energy of the particles, but it's not the total energy, it's the average energy of all of the particles. So if you added up the total energy and divided by how many particles there were, that would get you the average kinetic energy of the particles in a substance, and from that you can find the temperature of the substance. Generally, the more thermal energy there is, the more the particles are moving, and the warmer the object is. This generality does not apply to, say, objects that are going through a change in state, or during a chemical reaction between two substances. In the last lesson, you learned that there's forces of attraction between particles that hold the particles together. When those particles get moving faster, they can move further away from each other. This doesn't only apply to when a substance is changing from a solid to a liquid or a liquid to a gas, but it applies as the object is a solid. Those particles can move further away from each other as they move faster without changing into a liquid just yet. This is what we call thermal expansion. So when an object goes through thermal expansion, it gets heated up, the particles move a little bit faster, move further away from each other, and it increases the volume of the object. Throughout history, there have been a number of devices that have used the concept of thermal expansion to measure temperature. And these objects are called thermometers. You might ask, just how does a thermometer measure temperature? Well, that's a great question, and the answer depends on what kind of thermometer you're talking about. One of the pop-up thermometers, like you might use when you're baking a turkey, that uses a little spring inside of the device that as the spring heats up, it expands and it gets longer. And once it gets to a certain temperature, the spring has expanded so much that it causes the little red plastic piece to pop up. At that particular point, you know that your turkey has reached the particular temperature that you're shooting for. There's another common kitchen thermometer you might be familiar with. Those are the bimetallic strip thermometer. They usually have a long metal stem on one end and then a face on the other end that has a gauge for the temperature. These utilize the differing expansion properties of two different metals in order to move a coil. So they'll take a strip of metal and they'll weld basically another type of metal on top of it and coil it up. As the temperature increases or decreases, one of the metals will change more than the other, causing it to either coil even more into itself or uncoil. And when that twists, it moves a rod that moves a needle at the face of the thermometer and tells you the temperature of what substance it's in. The most common type of thermometer, which I'm sure you're familiar with, is the bulb thermometer. These are sealed glass tubes that don't let any air in or out of them. And inside of these tubes, there's a liquid. We used to use mercury back in the day, but now we've moved on to using alcohol, usually ethanol, in fact. At the bottom of the thermometer, there's a bulb that holds most of the liquid. And then at the top of the thermometer, where the scale is, all the numbers, there's a very thin, narrow path for the liquid to move. As the temperature of that liquid increases or decreases, it will expand or contract and give you a different number on the scale. Finally, we have the Galileo thermometer. This was the very first kind of thermometer invented, thought to have been invented by Galileo Galilei. In my personal opinion, these are one of the coolest types of thermometers there are. This is another sealed glass tube, but a much larger one. And inside of it, there are smaller glass bulbs that hold different types of alcohols or different liquids that have different density properties based on the temperature. The liquid inside of the tube is usually a type of oil, like mineral oil. And as the temperature changes and the temperature of the mineral oil changes, it'll cause the temperature of the different bulbs to change. And when that happens, they can expand or contract, as we've learned, and that changes the density of the liquid inside this bulb. When the density becomes greater than the mineral oil, the bulbs sink, and when the density is less than the mineral oil's density, they float. To read a Galileo thermometer, there's a little tag on each of the bulbs that gives you a certain temperature reading, and so whichever one you find is in the middle or closest to the middle is the current temperature. So, now that we know how thermometers work, we need to know how to read them. There are 3 different scales that you might be able to read a thermometer on. There's Fahrenheit, Celsius, and Kelvin. You're probably very familiar with the English system of Fahrenheit. There are only 3 countries in the whole world that use this temperature to talk about the weather. This temperature scale was developed by Gabriel Fahrenheit in the year 1714. He was a German physicist who's known for being the first one to use a mercury bulb thermometer. He chose the lowest temperature he could possibly create in his lab in order to be the 0 point of his scale. He used water, salt, and ice to create a temperature of 0 degrees Fahrenheit. And for the other end of the scale, he used 100. And to him at the time, that was about the temperature of the human body. So in the low end of the scale, he had the coldest temperature he could make in his lab. In the high end of the scale, he had the temperature of a human body. And eventually, we standardized that scale to where we know that 32 degrees Fahrenheit is the freezing point of water, and 212 degrees Fahrenheit is the boiling point of water. I don't like to make assumptions, but I'm guessing you've probably heard of the Celsius scale for temperature too. This temperature scale was created in 1742 by a Swedish astronomer named Anders Celsius. He wanted to create a temperature scale that had exactly 100 degrees between the freezing and boiling points of water. In 1948, it was named the official scale of the metric system, which almost all countries in the world use. On the Celsius scale, the freezing point of water is at 0 degrees Celsius, and the boiling point of water is at 100 degrees Celsius. Finally, there's a third, lesser-known temperature scale, and that is called Kelvin. This temperature scale was developed by a British inventor and scientist named Lord Kelvin. He invented the scale in 1848 when he was just 24 years old. In Lord Kelvin's scale, 0 is set at the lowest theoretical temperature that scientists have come up with. This is a temperature known as absolute 0. At absolute 0, all particle motion stops. Even in a solid, we don't have particles vibrating anymore. Again, this is a theoretical scale, and we've never reached absolute 0, but we've come pretty close to it. The difference between a degree of Kelvin and a degree of Celsius temperature is exactly the same. They're just set 273 degrees apart. So when we're talking 0 degrees Celsius, we're actually talking 273 degrees Kelvin. And when we're talking 0 degrees Kelvin, we're talking negative 273 degrees Celsius. So here are the 3 equations that you need to know in order to do temperature conversions. Make sure that you have these equations written down in your notes and that you use them frequently as you go through these problems. Once you've gotten the hang of practicing through temperature conversions, you should almost have these equations memorized. Let's head over to the board to do a few example problems to get you in the hang of using these equations to convert between different temperature scales. All right, so our first problem says we want to take 59 degrees Fahrenheit and convert it into degrees Celsius. So we're going to use the equation that says Celsius equals and we just plug in 59 degrees for F. So here we get and then you just plug and chug. So 59 degrees minus 32 is about 27 degrees. And then you take 27 times 5 divided by 9, and you get about 15 degrees Celsius. So 59 degrees Fahrenheit is equal to 15 degrees Celsius. Okay, next it says we want to take 25 degrees Celsius and convert it into degrees Fahrenheit. So we're going to use the equation that says Fahrenheit equals Pay special attention, we don't have parentheses over the whole thing this time. So instead of doing the Fahrenheit plus 32 then times 9/5, we'll do 9/5 times the 25 degrees Celsius. We'll do 25 degrees Celsius times the 9/5, and then add 32. So when we do that, we get 45 degrees plus 32 gives us a total of 77 degrees Fahrenheit. So 25 degrees Celsius is equal to 77 degrees Fahrenheit. This time we're asked to convert Kelvin to Celsius. So we're looking for Celsius. We use the Celsius equals. C equals K minus 273. K is 325. So we take 325 minus 273. We get that 325 Kelvin is equal to 52 degrees Celsius. Lastly, we're asked to take 100 degrees Celsius to Kelvin. We don't have an equation for that, but if you use this guy, you can probably figure it out. So if degrees Celsius is equal to Kelvin minus 273, just a very little bit of algebra, you get that Kelvin equals Celsius plus 273. So then we plug the numbers in. Kelvin equals 100 degrees Celsius plus 273. And so our temperature would be 373 degrees Kelvin. So 100 degrees Celsius is equal to 373. Hopefully these examples will help you understand how to use these equations. And the rest of the video was helpful in learning the difference between thermal energy and temperature, and how thermometers work.